Saturn, master of the rings. When we look up at the sky in our solar system, there is one planet that stands out from the rest. With its magnificent rings, mysterious moons, and enormous size, Saturn. This gas giant, which has captivated humanity's imagination for centuries, has been one of the most fascinating planets for scientists, not only for its beauty, but also for the secrets it holds. In this documentary, we will explore Saturn's formation, structure, rings, moons, and the exploration vehicles humanity has sent to this planet. Saturn is the sixth planet in the solar system, and the second largest planet after Jupiter. Its diameter is approximately 9 times that of Earth, and its volume is 760 times greater. However, there is an interesting detail. Saturn is the planet with the lowest density. In fact, theoretically, if there were a sufficiently large body of water, Saturn could float. This giant planet belongs to the gas giant class. In other words, it does not have a solid surface. A spacecraft attempting to land on Saturn would disintegrate within its dense gas layers before reaching the surface. Like several other planets, Saturn is visible to the naked eye when looking at the sky, and its magnificent rings are visible with the aid of a telescope. Saturn is among the most popular planets in the solar system. There is no clear information about the first observation of the planet, which orbits at a distance of 1.3 billion kilometers at its closest point to the Sun, and 1.5 billion kilometers at its farthest point. Saturn, which was observed in ancient Roman and Greek history, and became the subject of myths and legends, along with the discovery of axis and movement records created by Babylonian astronomers, was discovered in the modern world by Galileo Galilei. When Galileo observed Saturn, he thought that Saturn's famous rings were its moons, and even thought that the shape of the rings, which he sometimes mistook for moons, changed and disappeared based on his observations. The reason for this was Saturn's axial tilt, which is visible when viewed from Earth. The accumulation of elements left over from stellar deaths over millions of years is the fundamental factor in the formation of gas giant planets. In fact, all planets form in this way, but gas giant planets form by incorporating the surrounding hydrogen and helium gases into their bodies during the 1 to 8 million year period following the formation of a rocky core. To summarize the process, over time, the low-density hydrogen and helium gases in the surrounding area enveloped these cores under the influence of high gravitational pull. This accumulation continued until the masses of the core and the gas sphere were equalized. As a result, solid, small planets formed in the inner regions of the Sun's orbit, while gas giant planets, hundreds of times larger than terrestrial planets, formed in the outer regions of the orbit. Since Saturn is a gas giant planet formed in the outer orbit of the solar system, the theory of its formation process can be summarized in this way. There is no single, widely accepted theory explaining the formation of Saturn's magnificent rings. In fact, estimates of their age vary dramatically from one hypothesis to another. However, thanks to modern scientific advances, we now know that the rings are composed primarily of ice particles, with small amounts of rocky material, ranging in size from microscopic grains to objects several kilometers across. These particles move in near-perfect balance under Saturn's powerful gravitational influence. Although the rings appear as solid, continuous structures from a distance, they are actually made up of billions of individual fragments orbiting the planet behaves like a tiny moon of its own, colliding, separating, and constantly reshaping itself. This perpetual motion makes the rings a dynamic, ever-evolving system. One leading theory suggests that the rings formed from the remnants of a moon or large celestial body that once ventured too close to Saturn. Within a critical distance, known as the Roche limit, a body's own gravity can no longer withstand Saturn's tidal forces. As a result, the object is torn apart, leaving behind a vast cloud of debris that could eventually form the ring system we observe today. Another hypothesis proposes that the rings are made of primordial material left over from Saturn's formation, meaning they could be nearly as old as the planet itself. However, this idea conflicts with the rings' striking brightness. Ice particles exposed to space for billions of years would be expected to darken significantly due to micrometeoroid impacts and radiation, yet Saturn's rings remain remarkably reflective. At this point, data from the Cassini spacecraft has played a crucial role in reshaping scientific understanding. During its daring dives between Saturn and its rings, Cassini detected a continuous flow of material falling from the rings into the planet's atmosphere. This finding suggests that the rings may be much younger than previously thought. Some estimates indicate that if this rate of mass loss continues, Saturn's rings could disappear entirely within a few 100 million years. Saturn's rings are also structurally complex. The brightest and most extensive sections, known as the A, B, and C rings, are separated by darker regions, such as the Cassini division. Many of these gaps are created by gravitational interactions with Saturn's moons. Small shepherd moons help confine ring particles to narrow paths, shaping sharp edges and wave-like patterns within the rings. Within the rings, scientists observe spiral structures, density waves, and transient gaps, all of which reveal how delicately balanced the Saturnian system truly is. Even a minor change in the orbit of a small moon can leave detectable signatures across millions of kilometers of ring material. In this sense, Saturn's rings are not merely a visual wonder, but also a vast natural laboratory for studying the physics of gravity and orbital dynamics. Today, we understand that Saturn's rings are not permanent. Like all structures in the universe, they are born, they evolve, and one day they will fade away. We are witnessing them during a brief moment on the cosmic timescale. Perhaps this is what makes Saturn so captivating. Not only the beauty of its rings, but the fact that they are temporary. What we see in the sky is a silent reminder that the universe is not static, but constantly transforming. Saturn is one of the most remarkable planets in the solar system, not only because of its rings, but also due to the extraordinary diversity of its moons. To date, dozens of Saturn's moons have been confirmed, and this number continues to grow as discoveries progress. These moons range from small, irregular bodies, only a few hundred meters across, to vast worlds with complex structures that rival those of entire planets. The largest of these moons, Titan, is the undisputed centerpiece of the Saturnian system. Despite being larger than the planet Mercury, Titan concealed its surface for decades beneath a thick, dense atmosphere, composed primarily of nitrogen, with a complex methane cycle. Titan displays processes strikingly similar to those on Earth. Rain, rivers, and lakes exist there, but instead of water, they are made of liquid methane and ethane. For this reason, Titan is considered one of the most important targets in the search for life beyond Earth. Another extraordinary moon is Enceladus. Though only a few hundred kilometers in diameter, Enceladus has generated immense excitement within the scientific community. Powerful jets of water vapor and ice erupt from its south polar region, revealing the presence of a liquid ocean beneath the icy surface. The fact that this ocean is in contact with a rocky core makes Enceladus one of the strongest candidates for hosting life in the entire solar system. Other major moons, such as Mimas, Tethys, Dione, and Rhea, offer valuable insights into the history of the Saturnian system. Mimas is dominated by the enormous Herschel crater, so large that it nearly shattered the moon itself. Tethys reveals signs of intense internal stress through its deep fractures and vast valleys. Dione and Rhea, with their heavily cratered, ice-covered surfaces, stand as silent witnesses to billions of years of cosmic impacts. Saturn's moons do not exist in isolation. They are in constant interaction with the planet's ring system. Some moons orbit within or near the rings, guiding and sculpting the particles that make them up. These so-called shepherd moons play a crucial role in maintaining the sharp edges and defined structures of the rings. Material ejected from Enceladus, on the other hand, is the primary source of Saturn's diffuse E-ring. This intricate web of interactions turns the Saturnian system into a miniature solar system of its own. Each moon carries records of ancient events, while also participating in dynamic processes that continue today. Data from the Cassini spacecraft revealed that many of these moons are far more active and complex than scientists once believed. In the end, Saturn's moons are not merely cold, lifeless objects orbiting a distant planet. They are worlds where oceans may be hidden, atmospheres may form, and the conditions necessary for life might come together. To understand Saturn is to understand its moons, because they serve as silent gateways to the past, present, and possible future of the solar system. For centuries, Saturn remained a distant and unreachable world, observed only through telescopes. But in the second half of the 20th century, humanity developed the technology needed to reach out and touch this faraway planet. Every spacecraft sent to Saturn carried more than scientific instruments. Each one became a symbol of human curiosity, patience, and the desire to explore. The first spacecraft to encounter Saturn up close was Pioneer 11, which flew past the planet in 1979. Pioneer 11 performed the first direct measurements of Saturn's powerful magnetic field, atmospheric structure, and the unexpected complexity of its ring system. Though brief, this historic encounter paved the way for more ambitious missions to come. In 1980 and 1981, the Voyager 1 and Voyager 2 spacecraft explored the Saturnian system in far greater detail. Thanks to the Voyager missions, scientists discovered the fine structure of the rings, the gaps between them, and several previously unknown moons. These spacecraft revealed for the first time that Saturn's moons were not merely frozen and inactive bodies, but worlds with complex surfaces and rich geological histories. The true turning point in Saturn exploration, however, came with the Cassini-Huygens mission, launched in 1997. After a 7-year journey through the solar system, the Cassini spacecraft entered orbit around Saturn in 2004, becoming the first mission to study the planet and its system from within. For nearly 13 years, Cassini examined Saturn in extraordinary detail, from its turbulent atmosphere and vast ring system to its magnetic field and diverse moons. One of the most unforgettable moments of the Cassini mission was the descent of the Huygens probe, developed by the European Space Agency, onto the surface of Titan. In 2005, Huygens became the first human-made object to perform a soft landing on a moon in the outer solar system. By directly measuring Titan's atmosphere, winds, and surface composition, Huygens demonstrated that this mysterious world was far more complex than previously imagined. The data returned by Cassini Enceladus's icy crust, the dynamic atmosphere of Titan, and the ongoing evolution of the rings were all made possible by this mission. Cassini not only revealed Saturn in unprecedented detail, but also deepened our questions about where and how life might arise elsewhere in the universe. In 2017, Cassini concluded its mission with a bold maneuver known as the Grand Finale. After repeatedly passing through the narrow gap between Saturn and its rings, the spacecraft was deliberately directed into the planet's atmosphere. This decision was made to protect Saturn's moons from potential biological contamination. Cassini's final descent was a powerful demonstration of humanity's sense of responsibility in the exploration of space. Saturn, with its rings, its moons, and its enduring mysteries, reminds us of the vastness and complexity of the universe. Every spacecraft sent there carried not only data, but a story. The story of curiosity, courage, and the human mind reaching toward the unknown. Today, we no longer see Saturn as a distant point of light in the sky. We know it as a world with ocean-bearing moons, temporary yet breathtaking rings, and secrets still waiting to be uncovered. And perhaps most importantly, Saturn reminds us of this. The quest to understand the universe is also a journey toward understanding ourselves. And that journey is far from over.